any questions that anyone might have. So feel free to put any questions on there as we go along. So firstly, we'll just cover the agenda of what we're going to go through today. So as the title suggests, we'll be looking at replacing fluorescent luminaires, Raytec fluorescent luminaires with an LED retrofit, and challenging what that LED retrofit, that term retrofit actually means. And part of that, looking at some of the practical considerations and the brackets, the glands and the cables, which obviously form an important part of any installation. We'll define what a like-for-like replacement actually is. Again, challenge that like-for-like replacement, what it actually means, and how different manufacturers would propose a like-for-like replacement. We've got some data and look at some specific applications where we can use to compare the data and the two different approaches. We'll also look at how you can replace a 2x36 watt fluorescent with a smaller LED equivalent than you thought you possibly needed. And we also look at emergency performance, which is obviously a really important part of any installation. So that'll form a part which we'll cover at the end of this. So firstly, just a quick recap. If you're familiar with Raytec, you may have already read a white paper, LED versus fluorescent, which we released back in 2016. We're not going to cover too much of the differences between LED and fluorescent in this webinar, so I just want to have a quick recap over of what we found in that white paper, but it is available to download from our website if you want to take a look back through that. But we found that LED suffers from far less degradation than fluorescent luminaires over its lifetime, and it provides a longer life, requiring less maintenance over that lifetime. It's more suitable to harsh environments, better in extreme hot and extreme cold temperatures, and also the nature of LED also means that it's more durable and resistant to vibration, which obviously in a hazardous area environment can be something important to consider. The directional nature of LEDs mean there's a better control of light and less light pollution. Light's targeted exactly where it's needed. And we also found that it provides a more reliable emergency solution than a fluorescent luminaire. So they were a summary of the main benefits we covered in that white paper. And again, you can go back and through that at your leisure. But what we will focus on for this webinar is more of the practical aspects and how you can upgrade to LED and what the benefits of that will be between two different approaches. Okay, so fluorescent luminaires are used extensively, not just hazardous areas, but in all solutions across the world, and that means that the retrofit market and upgrading to LED, given that we know the benefits of LED, is a really big market. And so that's what we mean by the term retrofit in terms of upgrading from fluorescent to LED. But the LED fittings themselves should have some special features which make them a retrofit. So we're going to look at a few of these now. And there tends to be two main approaches to this. So what are the options? You may have seen these. Both of these are quite common options, so you may have some experience of them. But the first option we'll look at is fitting LEDs inside an existing GRP fluorescent housing. So because there are so many fluorescents installed worldwide, those manufacturers who have obviously made those fluorescents and sold those across the world want to capitalise on the upgrade market and be able to catch up some of that business where customers are looking to upgrade to LED and replace that existing fluorescent technology. One option to do that is to sell LED kits which replace the fluorescent tubes, so the control gear of the fluorescents can be removed and replaced by an LED kit. Different manufacturers have different ways of doing this, but it is quite a common thing to do, because like I say, manufacturers want to capitalise on that upgrade market and use those existing customers they have to upgrade to LED and use something which they can upgrade with it. And then option B replacing with a bespoke LED luminaire. So this is entirely new fitting. You're not keeping that existing housing, you're replacing the entire new fitting. They should be designed with the existing fluorescent fittings in mind, so in terms of dimensions and some of the other parts which we'll look at in a little bit more detail shortly, but they should be designed with those in mind to increase ease of installation. But crucially, the housing is designed to best suit the LEDs, or at least it should be. So option A could be seen as a quick, low-cost fix. We'll look at that in a little bit more detail as we go on, but fundamentally, we say this is wrong. So Raytec is very much in the option B camp in terms of we see the importance of using a bespoke fitting, which has the bespoke housing and creates the best environment for the LEDs themselves, rather than fitting the LEDs inside a housing which has been designed for a previous technology. So fundamentally, we say that option A is wrong, but we need to look at this in a little bit more detail and understand why that is. So why is a bespoke LED fitting so important? So it comes down to thermal management. Thermal management is critical to the performance of the fitting and the long life which it can offer. GRP is a very poor conductor of heat. So if you think back to option A, which we looked at, it's using that same GRP housing. And because GRP, or glass reinforced plastic, is a poor conductor of heat, it means that heat is trapped within the luminaire, and with it, the LEDs get hotter. So what does that mean if the LEDs are getting hotter? So a hotter LED will mean it provides a shorter life. It means it will degrade faster, and it'll mean ultimately that it'll be less reliable. In contrast, if we're able to keep the LEDs cool, we get the flip of that. So you'll have cool LED means longer life, lower degradation, and more reliability. And so what you really have to think is that if you're upgrading to LED in the first place, it's because you want to take advantage of the benefits which LED has to offer, which is long life, low degradation, and increased reliability and performance. So if you're upgrading to LED, then you need to make sure you're taking advantage of those benefits, and to do that, you need to make sure that LEDs are kept cool, and that's why a bespoke fitting with proper thermal management is so important to that. So with an understanding of the importance of thermal management and understanding that GRP is a poor conductor of heat, and putting LEDs inside that existing housing is going to be bad for them, we can say that option A is a poor LED retrofit. In contrast, option B, we're saying that it's bespoke housing. It's providing that it has proper thermal management, because although it might be specially designed for LEDs, the manufacturer has to still take efforts to make sure that it's the thermal management is done correctly. But if that's done so, then we can say that option B is a good LED retrofit. And also, just to come back to option A for a second, so we said that it may be a quick fix, and while it may be that, we don't, a quick fix isn't necessarily the right fix. Plus, it may not be as simple as you think. Some manufacturers may make it quite simple to put that LED kit inside, but others, it may not be quite as simple as you might think. Plus, the cost of these LED modules could actually be as much or exceed the cost of a new bespoke LED fitting. So from a cost-effective point of view, again, option A might not be as cost-effective as you might have thought. So next slide, we're just going to look at option B in a little bit more detail. We'll focus on that for the rest of this section. So looking at some of the practical elements. So with any retrofit solution, ease of installation is key, because you're taking down an existing fluorescent and you want to upgrade to LED. You need to be able to do that quickly, easily, and cost effectively. So the first thing we're going to look at is dimensions. So dimensions, keeping dimensions around the same as your existing fluorescent is really important. Keeping the dimensions the same will mean you can use the same cables, because they have to travel the same distance, not having to travel further and stretch inside a smaller fitting. By keeping the fitting the same size, the cables can be kept at the same length, and the same cables can be used. And it also means that if you have an existing space or an existing restriction on where you have to fit the luminaire itself, then that luminaire is going to fit inside there without any trouble if your existing fluorescent did so the same. So dimensions are the same for that, and also for cable. fixing centers in the back of the unit. Keeping the same fixing centers will ensure that you can use the same bracketry. Again, it makes it much easier and quicker for installation if you can just take down the old fitting, keep those same brackets in place, and fit your new LED luminaire using those brackets. And of course, you're going to save on cost. And lastly, cable entries. So again, cables is important, that you can use the same cables that's going in the same location, traveling the same distance, but also the cable glands. If you have the glands by using a luminaire which uses the same size glands, the same spec of gland, then it means you can use those same glands inside your new installation or new LED fitting, which again is going to make it quicker and also reduce the cost. So by taking these elements into account, the dimensions, the fixing centers and the cable entries, and keeping those equivalent with your new LED fitting is going to mean that you have a plug and play replacement, which is going to make installation faster, easier and less costly ultimately, which is obviously what we all want. So defining a like-for-like replacement. So we know that we need to keep the glands, the dimensions and the fixing centers the same, but how do we actually define what a like-for-like replacement is? One of the first questions you might have is, will upgrading to LED reduce your operating costs or your energy costs? The answer is yes, it will. There will be, you should expect to see some reduction in energy costs on your LED fitting, but the saving won't be huge, and we've got a little table which we'll show you in a second which covers that. But the key message is going to be that the biggest savings are going to come from maintenance, from the longer lifetime, reduced number of maintenance interventions, and we're going to look at this in some more detail later on the white paper in the webinar. Sorry. So this is a table I mentioned. So this gives you a comparison of the two equivalents. So you got on the left hand side your 2x36 watt fluorescent running around 72 watts, and then on the right hand side the equivalent Raytec Spartan WL168 luminaire, which is designed with those same dimensions and power. So as you can see, there'll be a small saving in energy, but the biggest saving is going to come from maintenance. But one key thing to make sure to take note of on this slide is that you can see that the lumen output figures are different. So a typical 2x36 watt will give 6,700 lumens, but that'll be at source, and the Spartan WL168 will give you 6,800 lumens for a zone 1 fitting, but that's delivered, so it's quite different, and we're going to come on to what those two mean and what the impact of those two figures are later on. So just going back to the slide, sorry. So one thing we want to determine is what actually is a like-for-like replacement. Typically, you replace a 2x36 watt with a 4-foot LED unit. We want to just look at the differences between the 2-foot and the 4-foots and see what kind of impact that has actually on a graph and what performance that will give you. So we've got a quick study to look at here, a practical example. Again, this was covered in our white paper, which I talked about at the start of this session, so you may be familiar with that. If not, well, again, you can download that at the end and have a look through that. But this is a quick recap in terms of a study which we did as part of that white paper. So we looked at an installation of 20 luminaires, obviously quite a modest size, but just gives you an idea. We compared a traditional zone 2 GRP fluorescent luminaire with one of our zone 2 LED Spartan luminaires. We looked at two variables, so the lumen output and how that differed against different temperatures. So I think we went from 0 to 60 degrees and how that, minus 30 to 60 degrees, and what effect that temperature has on the lumen output. And we also took into account degradation of those fittings and any maintenance considerations which will be done as part of that. So like I say, the white paper goes into this in a little bit more detail if you want to download that, but this is a sort of recap and how we reach some of the data which we'll look at on the next 2 or 3 slides. So this graph shows initially with the output shown on the lines between the WL168 and WL84, which are traditional 2-foot and 4-foot LED units, which replace traditionally a 2x18 watt for the 84, a 2x36 watt fluorescent for the 168. And so this first graph is the initial performance out of the box, brand new. So we'll overlay the fluorescent data on here, and the first thing you'll notice is that the shape of the lines is very different. The reason for that is down to the temperature and the effect that has on the output. So we talked earlier about how LED is very constant. It's suitable for extreme temperatures, and you can see that by the straight nature of the line. There's some fluctuation there across temperatures, but very little. But in contrast, the fluorescent across different temperatures, especially in the extreme cold or the extreme hot, differs and fluctuates significantly. The second thing you'll notice is that the line on that graph should actually, on the bottom fluorescent, should actually say 2x18 watt, not 2x58 watt. But what that tells us is that the 2x18 watt, which would traditionally compare against a WL84 2-foot LED, is much lower down on that line, to the point where the 2x36 watt is actually outperformed across a lot of temperatures by the traditional 2-foot LED fitting. The reason for that is down to that source and delivered at source and delivered lumens, which we looked at earlier. So the fluorescence is compared to LED is very inefficient. It'll lose a lot of its output down to inefficiencies, and also the light not being directed where it's needed. So that, as a result of that inefficiency, it means that although the lumen figures are very similar on paper, in a practical situation, you're not going to get the same output from a fluorescent as you would with an LED. And you'll see on the next graph, which goes to 8,000 hours, which is around 1 year of operation, that's going to be highlighted further. So we move to 8,000 hours around 1 year. So again, LED suffers from very little degradation, so those lines have moved very little. In contrast, the fluorescent suffers from greater degradation, so that those whole lines have shifted down to the point now where the performance gap between the WL84 and the 2x36 watt is much smaller. So only in the very optimum conditions is the 2x36 watt outperform that WL84, so around 0 to 20 degrees. And the general degradation has suffered quite significantly. And then moving on to 12,000 hours, so just under 18 months, we can now see that line, that 2x36 watt line, is now moved down below that WL84 completely, and that's being outperformed on all temperature levels. So what does this data tell us? So the first thing it tells us is obviously the suitability of LED to extreme temperatures. So when it's very hot or very cold, we saw that LED would perform much better, and as a result of that, the two fluorescent options were suffering quite significantly. And due to the rate of degradation and because of the inefficiencies, a 2-foot LED luminaire can actually outperform a 4-foot fluorescent luminaire, either from new, when those temperatures are having an effect, so below freezing or above 27 degrees or around that, and then after around 1 year of operation, 18 months of operation, it's being outperformed in all temperatures. So that's down to the degradation and the effect that has. So with that understanding, the question you might be asking is, should you be using a 2-foot LED unit instead of your, so when you're replacing a 2x36 watt, should you be using a 2-foot LED instead of the traditional 4-foot LED, which you would use normally? So for new installations, the answer to that is absolutely. There's no existing infrastructure to be aware of. You have no existing restrictions on what you can do with that installation, so absolutely you should use a 2-foot LED unit instead. But if you're replacing existing fluorescents, it's a little bit more complicated. So the issues we talked about earlier in terms of ease of installation and the cost of that. You still need to consider the cost of the cables, the glands and the brackets. And obviously if you go for a 2-foot LED fitting, which is obviously much smaller than your 2x36 watt, the chances are you can have to recable, use new brackets. Well, the brackets may be okay, but certainly they'll be more expensive with the cables and the glands which you have to use. So we can say that it's probably not cost effective to go from a 2x36 watt down to a 2-foot LED if you have to consider all these elements. But there's another solution. So again, if you're familiar with Raytec, you may have seen this product before, but just introduce it. This is the WL84-1200. Effectively what this is a luminaire which has the power of a 2-foot fitting, which we've already shown provides equivalent or actually better output than a 2x36 watt fluorescent, but it's been housed in a longer body, which is going to give you the benefits of that retrofit solution, which is the equivalent of that 2x36 watt existing body, which you need to have that benefits for using the cables and the glands and bracketry. So effectively this gives you the best of both worlds. The lower consumption is going to mean that you halve your energy costs while still giving like for like performance, while having those dimensions of the existing 2x36 watt unit is going to mean you can reduce the infrastructure costs on new cables, new glands and that sort of thing, but you can have that speed of installation, ease of installation, which is going to keep your cost to a minimum. So this is giving you really the best of both worlds in terms of low consumption, the same dimensions, which give you all the benefits together. So now we're trying to look at a typical installation or an application, sorry. So a fairly modest size of 200 2x36 watt fluorescents, running at 72 watts. I'm looking at replacing those with the WL84-1200 units, which run at 34 watts. So first off, from an energy saving, that's 38 watts per unit that you'll be saving, which equates to 7.6 kilowatts per hour over installation of 200 units. From a cost perspective, this works out at around £1 per minute or £1,000 per year across the installation. But obviously 200 units, 200 fluorescent or 200 LED units is quite a modest size application. If you're looking at large applications such as drilling rigs or refineries or that sort of thing, then the chances are you'll have far in excess of 200 units installed. And by upgrading those to LED into that 1200 unit, the benefits of that and the cost savings are going to be multiplied also. And also just to look at a couple of considerations which you may. So obviously the benefit here is also energy savings and what that can mean. So yes, there's an energy saving there which will help to save costs. Something you may not have considered is applications which rely on the use of generators. So by halving or almost halving the amount of energy using, you're also freeing up 50% more generator capacity, which is in upgrading to lighting to reduce that, because the expense of upgrading generators could be significant. It's probably going to be a lot cheaper to do that by upgrading your lighting and freeing some of that capacity up rather than extending that generator system. So it's reducing energy savings, so it's reducing energy costs, sorry, and it's also halving that usage so you can use that for other equipment on site. But of course, what we've taught throughout this is the benefit of maintenance. And so what this means, or using a WL84-1200 unit or a specialist fitting like this means, is that you can really you can have the benefit on many different fronts. So you can have the ease of installation. You've still got that same body, which you can use to replace the existing 2x36 watt units. You can reduce your maintenance costs, because again, it's the benefit of LED and the bespoke thermal management which is being used there to keep the LEDs cool and give you that performance benefit, and also the energy savings as well. So you're really hitting this on all different fronts. Likelihood is the biggest benefit is still going to be through maintenance by reducing those maintenance interventions, but obviously some of the ideas we talked about reducing generator capacity and that sort of thing could have significant cost savings behind it too. So another benefit which I want to just quickly go through when upgrading to LED is the boost in emergency performance and the increase in reliability of the emergency system which it can provide. So why is LED more reliable? So 4 main factors here. The first one is that the output remains constant over the backup period. So a constant issue with fluorescent luminaires was that during the duration of the output period, so say for 3 hours, the output would degrade over that 3-hour period. So you end up with a much smaller output by the end of that than you would at the start. But in contrast, an LED unit will remain constant. There's going to be no drop over that backup output period. So obviously for an emergency scenario, you want that level of light to remain at the level it begins with and not to degrade over time. So that's an important thing to consider. Less degradation of components. So effectively, with an LED fitting, there's fewer things to go wrong. Fluorescents tend to rely on starters or ballasts to make that switch over to the emergency mode, and these kind of fail once we're switching to emergency, which is obviously the last thing you want in an emergency scenario is to find out that a starter or ballast has failed. An LED unit is more simple, and you're less likely to have an issue like this, which is obviously increases the reliability of the system. We talked about the consistency in harsh temperatures and how LED doesn't fluctuate. Exactly the same in emergency scenarios, but obviously because in the emergency scenario you're operating at a percentage of the original, or more often than not operating at a small percentage of the total fittings output. These fluctuations in temperature and reducing the output is going to be magnified. So that could be quite a noticeable problem with the fluorescent, but obviously with LED, which is more consistent and more suitable for extreme hot and extreme cool, that's going to be a much better solution. And lastly, if you're familiar with Spartan and Raytec products, you'll know that our products go up to 100% output in emergency mode, which isn't possible with existing solutions. So obviously that's a trade-off between duration and output, but this is ideal for certain applications such as lifeboat evacuation areas, or applications where maximum output is required for a shorter period of time. And also just to pick on one thing which I haven't included in this slide is redundancy. So a fluorescent luminaire is obviously relying on 1 or 2 fluorescent tubes. If one of these fails, you've either lost 50% or 100% of your output, which is obviously going to be a problem in emergency mode. But in contrast, an LED fitting relies on a much higher number of light sources, 84 or 168 LEDs in the examples we've used in the Raytec products. And by having those many more light sources in the unlikely event that there is a problem, it means that you're not, as an emergency scenario, you're not going to be left without light. There's always going to be light sources there to pick up that loss. So that's an important thing to consider, as well as the redundancy and the impact of a failure of 1 or 2 tubes could have on an emergency scenario, or a normal operation for that matter. Modern emergency fittings are also emerging, which automatically cycle the batteries. Would traditionally be a manual process of checking the luminaires, checking that they're providing the right duration and the right level of output. So you may be familiar with the intelligent emergency products which we've recently launched in the last few months, which build in more automation into the testing procedure. So the products use an inbuilt microprocessor to automate those testing procedures. So it becomes something which is automatic and no longer relying on manual cycling or manual testing to make sure that they're operating as they should be. So this allows the commissioning to happen automatically, so it will actually deplete and recharge the batteries 3 times prior to the installation, perform frequent health checks and communicate the status of those health checks via an LED indicator, which you can see the different colors and examples of that on the image there. And also quickly just to run down the key features, which you can see down the right hand side of the slide. These are really important things which you should be considering if you're looking at an emergency luminaire, and whether luminaire features these different things. So the first one is random testing. Because the cycling or the testing is happening automatically, it should happen at random times to ensure that, especially for large installations, that you're not going to have a high number of luminaires which are going through a testing period at the same time. You want those to happen independently at different times, so there's never a high proportion of the installation going through testing at the same point. Second one is reserve capacity. All luminaires should always retain some reserve capacity even when going through testing. This means that if you were to switch to, or if an emergency scenario was to occur while the luminaire was going through testing, there would at least be some battery charge in there to provide output, which could obviously be really important, especially for evacuation scenarios or that sort of thing. So it's important that they always retain some capacity and don't deplete completely. And the last one is 100% output. So when the luminaires are going through testing and they're going through the weekly checks or monthly checks, then during that point the luminaire should still provide 100% light output. It shouldn't drop to 20-30% of its original output, because obviously that has an effect on the site. You don't want that to happen. You want that luminaire to maintain 100% output throughout its testing. And so the benefits of this is ultimately less reliance on human intervention. They're happening automatically. The testing is happening automatically. There's less chance for the test to be missed. There's less chance for neglect. So it really improves reliability. Maintenance becomes a lot easier. The process of testing the luminaires is much faster. It's just a case of monitoring the luminaires and that LED health indicator, and that all luminaires are okay. There's less, which comes down to that less intervention, but it also means it's quicker and less costly because you're running on less resource and less time to go and do that testing. Provides safer testing conditions. Testing can be done, or it can be monitored remotely. Because of that LED health indicator, there's less human intervention, less risk. And finally, and ultimately, it provides a more reliable system. So all these together, because the maintenance becomes easier, because there's less chance of mistake, less reliance on human intervention, it creates a safer environment and a more reliable solution, which is ultimately what we're trying to do with any hazardous area luminaires, to improve safety. So just a quick summary of what we've been through this webinar. So we've discussed the importance of using the right retrofit solution, which is, as we discussed, a bespoke fitting rather than fitting LED modules inside existing GRP housing. We went over some of the issues of doing that in terms of the lifetime of the LEDs and the performance which it offers. We looked at the importance of selecting a retrofit luminaire which uses the same cable entries, the same fixing centers and dimensions, and which are critical for easy installation, which should obviously, the ease and cost of installation should be a really important factor given the amount of fittings and the size of the retrofit market. We looked at how Twofer LED fitting can actually outperform a 2x36 watt fluorescent fitting in the majority of the scenarios, especially due to the degradation of that fluorescent and the fluctuation in extreme temperatures. And lastly, we looked at how specialist fittings like the WL84-1200 can be used to help maximize benefits on numerous different fronts. So they make installation easier. They help reduce maintenance costs, and they also help reduce energy costs as well. So that's a summary of what we looked at in this webinar. Just a quick recap. Again, I'm not sure how many of you are familiar with Raytec products, but the two graphs, or the three graphs we looked at earlier, where we were looking at the 2 foot and 4 foot LED units, which are WL84, WL168. So traditionally, in terms of the size of the luminaires, the WL84 replace a 2x18 watt, and the 168 will replace a 2x36 watt fluorescent. And then the retrofit solutions we looked at as well, also specialist fittings, so the WL84 1200, which has the power of that 2 foot LED, but in the larger body it replaced 2x36 watt fluorescents. We also do something similar with the WL168-1500, which is designed to replace 5 foot or existing 2x58 watt fluorescents. So again, that's another retrofit solution for certain, slightly more of a specialist product, that one, but again, we do have a solution for it. There's a couple of resources I can point you in the direction of before we go. So in terms of getting some help to specify which linear product is right for you, you may or may not have seen our linear specification guide. Again, we'll share these slides out after the webinar, so you can access the links there. But this can help guide you on the right linear which you need for your application, and it has some information there on retrofit solutions and the different options and spec which you can select. So that's something I'd recommend you take a look at. And lastly, just looking outside of the fluorescent upgrade market, but obviously the similar things can also apply to floodlights and other types of luminaires. So we do have an LED upgrade guide for our other products, where we've done similar sort of research and data into in terms of comparing the technology like high pressure sodium or metal halide and what the equivalent Raytec product will be for that, and an idea of the potential savings you can make by upgrading. And again, the link's there at the bottom for that. But that covers everything we're going to go through. So thanks very much for attending. Like I say, I'll have a quick look in a second to see if there are any questions, but thanks very much for everyone who's taken the time out. And like I say, this has been a CPD approved webinar. So if that's of interest, we'll send out an email afterwards and you can request a certificate on that. But you can also find this session listed on the CPD website as well if you want to request a certificate that way. So thanks very much for your time. Have a quick look. So I'll hang around for 2 or 3 minutes to see if there's any questions. But if not, thanks very much for your time and attending this webinar. Thank you. Bye-bye. I can see a hand raised there, little hand icon from Jose Pinto. Jose, if you do have a question, there should be a little question section on your screen which you can use to type the question in, and I should be able to see that. So if you do have a questions, please pop it in there. Or alternatively, you can we can pick this up afterwards. Thank you. So a question from Jose: how can use the same brackets from the already installed fluorescent, which have defined fixing points different from one brand to another? So yeah, it's a good question. I mean, so what we do at Raytec is we try to cover for different scenarios. So we have 3 fixing points in the back. So we have M8 and M6 tapped holes. And traditionally these will, because the fluorescents tend to be based on the same sort of design and same concept, those fixing centers tend to be around the same location, and they may have different size or different size holes, which is why we have the M6 and the M8 tapped sizes. But generally those brackets can be used across different sizes. The key thing is obviously is that you have a fixing center which takes the same size M6 or M8 bolt, which we have both options for. But generally they tend to be very similar on different fluorescent fittings. If there's something you're not sure on, or there's a different type of fitting which you're not sure on, then that's something we can take a look at. But it's not an issue we've ever had a problem with in terms of not having brackets to sort. If there's something which is particularly different or unique, then we also have a range of dedicated brackets for our linear products which can be used. But if you do have any examples, please feel free to send those over, and we can take a look and see if there's any specific challenges for that. There doesn't seem to be any more questions at the moment, so I'll end the webinar there. Thanks very much again for your time. Like I say, we'll send an email around after this webinar with a copy of the slides. If anybody does have any other questions or anything else they want to raise, either do so through that email or through any of the Raytec team. We'll be happy to help, and we'll do our best to help you with any questions you do have. So once again, thanks very much for your time, and appreciate your attendance. Bye-bye.